So hello students, welcome to this my session on the mathematics. So in this session we are going to discuss first the Lagrange mean value theorem and then after we will solve the three questions of the mathematics. So let us start with the Lagrange mean value theorem. So Lagrange mean value theorem. So what does Lagrange mean value theorem says? Is it says that if there is a function fx that is continuous in the closed interval a to b and also differentiable in the open interval a to b. So what is the condition to apply the Lagrange mean value theorem? That the function fx should be continuous in the closed interval a to b and it should be differentiable in the open interval a to b. Then it satisfies the condition that there exists a number c, there exists a point c, sorry, there exists a point c in between, there exists a point c in between a to b, open interval a to b, such that f dash c is equal to fb minus fa divided by b minus a. So what this Lagrange mean value theorem says, that if there is a function that is defined and continuous in the closed interval a to b, the domain of the function can be larger than the closed interval a to b, but it must be defined in the closed interval a to b and must be continuous in the closed interval a to b, and it should also be differentiable into the open interval a to b. Then there exists a point C in the open interval a to b such that f dash c is equal to the value of the function at the point b minus value of the function at the point a divided by b minus a. So let's understand this understand this theorem through a graphical interpretation of this function on xy axis. So let's say this is the x axis and it is the value, it is we are representing the x on this axis and we are representing fx on this y axis, and this is the point a, x is equal to a, and this is the x is equal to b, and the function is continuous in the closed interval a to b. The function is continuous in the closed interval a to b. Let's say now this point will be a comma f of a and this point will be b comma f of b. So the theorem is saying that there exists a point C in open interval a to b, let's say this is C, where f dash c means the slope of the tangent that is drawn on the point this c comma f of c. If we draw a tangent at this point, then the slope of the tangent will be equal to f dash c equal to fb. That f dash c will be equal to, according to the theorem, fb minus fa upon b minus a. That will be the slope of this line on the xy axis in the xy coordinate system. If we calculate y minus y2 minus y1 upon x2 minus x1, that will be the slope of the line that is joining x1 comma y1 to x2 comma y2. So here fb minus fa upon b minus a will be the slope of this line, and the theorem is saying that the slope of this line will be equal to the slope of this line, that is the tangent drawn on the point c comma f of c. So how we can understand this? So if we draw a tangent at the point a, let's say there's a tangent at the point a, so we can draw a tangent like this, and if we draw a tangent at point b, it will be about the similar to this x-axis. So this is the tangent at the point b, and this is the point tangent at the point a. Now the tangent at the a has a slope less than the slope of this line, and at point, let's say this, if we proceed this line further, at point P, we can observe that the slope of this tangent at the point B is larger than the slope of this line that is joining point A and B. Let's say this point is A and this point is B. So what we can observe here from that, what we can observe from here, that the slope of the tangents are going to continuously increase. Here we can draw that this is the tangent. If we draw a tangent here, the slope of the tangent will be somehow larger than the slope of this tangent that is drawn at the point A. So the tangent of the tangent that are drawn on this curve f of x, that the slope of those tangents are going to continuously increase from the point A to B. So if the tangent is going at the point A, the tangent of that the slope of the tangent is less than the slope of this line, and at the point the slope of the tangent is larger than the slope of this line. So we can say that there will be a point in between A and B where the slope of this tangent will be equal to the slope of this line. There will be a point in the between A comma B where the slope of the tangent will be equal to the slope of this line that is joining A and B. So we can directly interpret from this diagram, and we can understand the Lagrange mean value theorem through this diagram. And if we want to get a more exploration on this theorem, we can take an example and understand better in the better way. So let there is a function fx is equal to x square minus 4x minus 3 is equal to 0, and we are taking a convergence interval from point A to B, that is 1 to 4. So as we know that the function is defined and continuous in the for all the real numbers, and also differentiable for the all real numbers. So it will be also continuous in the closed interval 1 to 4, and also differentiable into the open interval 1 to 4. So it satisfies the both condition of the Lagrange mean value theorem. So if you apply the Lagrange mean value theorem on this, so it will say that there will be a point in the interval 1 to 4, open interval 1 to 4, for that f dash c will be equal to fb, that means f4, minus fa, that means f1, divided by b minus a. Okay, so if we calculate fb, so fb will be equal to 4 square minus 4 into 4 minus 3 is equal to 0, that is equal to minus 3. And if you calculate f1, that will be equal to 1 minus 4 into 1 minus 3, that is equal to minus 6. So the value of this expression f4 minus f1 upon 4 minus 1 can be written as f4 will be minus 3 and f1 is minus 6. So f4 minus f1 upon 3. Okay. So now this value will be equal to 1 minus 3 plus 6 upon 3, that is equal to 1, 3 upon 3. So let's find a point. Let's see that if there exists a point in between 1 and 4, for that f dash derivative of the function at that point is equal to 1. So let's say the point is C. At the point where we find the derivative of the function is equal to 1, for that point, if the x is equal to C, then we can write that f dash C at that point will be equal to 1. Okay. So f dash is equal to 1. If we say f dash x, we find f dash x, we take derivative of the function f dash x, that will be equal to 2x minus 4 minus, no, 2x minus 4, x square minus 4x minus 3. If we differentiate that function against x, then we get 2x minus 4. So now write f dash c. So f dash c will be equal to 2c minus 4, and that is equal to 1. So c will be equal to 5 by 2. Now we can observe there is a 5 by 2 point lies between open interval 1 and 4. So through this example, we can understand that there exists a point x is equal to 5 by 2 in the open interval 1 and 4. For that, the f dash c is equal to fb minus fa. This value is for fb minus fa, f4 minus f1 upon 4 minus 1, fb minus fa upon b minus a. So this is an example through we can understand the Lagrange mean value theorem in the better way. Now we are going to solve 3 questions.